Welcome to Knowledge Base. We have a question here that says, find the magnitude of the resultant force in the system of the two forces shown below. So this is the system of forces. We have force F1 with a magnitude of 5 Newton and force F2 with a magnitude of 7 Newton acting in this direction and this direction as shown. The angle of separation between the two forces is given as 30 degrees, and both forces are acting on an object at a point O. We are told to find the resultant of these two forces F1 and F2 acting at an angle of 30 degrees. The resultant force is a single force that represents the effect of these two forces at this point O. To obtain the resultant force, we are going to complete this shape into a parallelogram in this form. So we complete it into a parallelogram, and this represents the resultant force R, which is the single force that represents F1 and F2. You will agree with me that in this parallelogram, if this side of the parallelogram is 5 Newton, obviously this side will be 5 Newton, and there will be an angle here. We'll come back to this angle shortly. So if this is 5 Newton, then this is 5 Newton. Now, if we look at this triangle here, this triangle O, R, and F2, that is this triangle, you can find out that we have two sides of the triangle, 7 Newton and 5 Newton, and an included angle. How did we get 150 as the included angle? This is angle 30, and this angle here and this one here are adjacent angle of a parallelogram, and adjacent angle of parallelogram sum up to be 180 degrees. So if this is 30, then obviously this adjacent angle is 150, because 150 plus 30 will give us 180 degrees according to the theorem. So we have two sides in this triangle, we have two sides given and a known included angle, and we are looking for the resultant R in this triangle. When we have this kind of triangle, we can find the third side of the triangle when an included angle is known by using the formula known as the cosine rule. So we are just going to write the cosine formula or the cosine rule equation, and this is it. From this triangle ORF2, this triangle here, the resultant R square is equals to F1 square plus F2 square minus 2F1 F2 cos theta, where theta is the included angle here. So this is the cosine rule. We are just going to substitute the values into this formula, so that R square is equals to 5 square, because F1 is 5 square, is 5, plus F2 is 7, so we have 7 square, minus 2 times 5 times 7, which is F1 F2, times cos 150, because the angle between the two forces 5 and 7 is 150. So if we solve this further, we have that R square is equals to 5 square is 25 plus 7 square is 49 minus 2 times 5 is 10 times 7 gives us 70 times cos 150 degrees. If you put this in the calculator, it gives you minus 0.866. So let's continue further. We now have R square, 25 plus 49 gives us 74, minus 70 times minus 0.866, minus times minus gives us plus, 70 times 0.866 gives us 60.62. If we add this together, we have that R squared is equals to 134.62. We are looking for the resultant R and not R squared. So to obtain R, this square will cross the equation sign to form a square root, so that R is equals to the square root of 134.62. We are taking only the positive value of the square root because the negative is invalid in this scenario. So the square root of 134.62 is equals to 11.6, and that gives us the resultant force as 11.6 Newton, and this is the final answer. Please try this. What would the magnitude of the resultant force be if the angle between the forces at point of application O is 60 degrees? The question is saying, what if this angle is 60 degrees? What will be the resultant force? Please put your answer in the comment section. Please like, share, and comment on our video. If you are watching our video for the first time, please follow our page to enjoy more of this kind of content. Most importantly, please share the content to other people so that they will enjoy exactly what you are enjoying. And that is one way to encourage us to continue making interesting videos. Once again, thank you for watching.